Okay, this is lesson 87, factoring special products. This is actually one of the easier things that we've done with factoring, if you can identify those patterns. And I've said it many times in class, identifying patterns can only help you. Can you do the questions without being able to see them? Absolutely. But you're making a lot more work and a lot more thinking for yourselves. The two types of special products we talked about were a difference of two squares and perfect squares. What I'm going to look at is a few examples of differences of two squares. They're easier, they're quicker, and we can go through a few at the same time here. We'll start with question number 1. I have an x squared minus an 81. The very first thing I should notice here is I only have two terms. Usually, when we are factoring, we are dealing with three terms, like this one. This only has two terms, so the moment I see two terms, I should think, is it a difference of two squares? Before I start solving any problem involving factoring, I need to ask myself, is there something I can take out of all terms? There's nothing I can take out of that x squared and that 81, so I'm going to go ahead with my factoring rules. If I have two terms in which both are perfect squares, I can take the square root of an x squared, I can take the square root of an 81. Excellent. The square root of an x squared is an x, the square root of 81 is 9. My rules for a difference of two squares say, if both numbers are perfect squares, my binomial is always one with a minus and one with a plus. That's it. Just that simple. These are perfect squares. I can square root both values. The square root of an x squared is x. The square root of 81 is 9. And since it's a difference of two squares, I need to have two different signs. Yes, this is a subtraction sign, therefore I need to have two different signs. If that were a plus sign, there wouldn't be anything that we could do there. Nothing. Since it's a minus sign, then yes, we can use our rules for a difference of two squares. And in there, the word is difference. I have to have a difference in my original problem as well. Let's go ahead to number 2 then. Number 2, I have a 3x squared minus a 27. If I look at this, 3 is not a perfect square, and neither is 27. But remember, whenever you are working with factoring, you have to ask yourself before you can do anything, can I take something out of both terms? In this example, yes, I can. I can take out a 3. If I take out a 3 here, I'm left with x squared minus a 9. Perfect. Now I have a difference of two squares. This is a square and this is a square, and I'm taking the difference of them. Rule says I take the square root of the first term, square root of an x squared is an x, square root of the second term, square root of a 9 is a 3, and I need one with a plus sign in between and one with a minus sign in between. But I can't forget about that 3 that goes on the outside. Pretty easy. Easy peasy. We'll do one more like this. Let's look at 11. Because 11, I have an exponent of 3. Kind of confuses students, but I'm not doing anything different. I still have to take a look at both of those terms and ask myself, can I take something out of both of them first before I begin to do anything? The answer is yes. I can take an x out of both of those terms. That would give me an x squared minus 100. Now I can go ahead and ask myself, is this a difference of two squares? Yes, it is. I have an x squared and I have 100. Both of those are perfect squares. The square root of an x squared is an x. The square root of 100 is 10. I need one with a minus and one with a plus. And can't forget about what I took out to begin with. That's all there is to a difference of two squares.